Okay, good morning. So I'll start today principle of separation, particle settlement, emulsion, coalescence and electrostatic separation. Electrostatic coalescence. Now you can see this right side picture, just a cross section of separator you can say. Like if I take cross section here, XX section, so it will be looking like this circular section, and top layer will be gas because density will be lower or gravity will be lower than other fluid. Then there will be one foamy layer maybe, then oil water interface, there will be like emulsion layer or mixed layer will be there, then water, then solid based on the gravity. Solid means sand may be there, sand is heavier, so sand will be settling at the bottom, where gas is lighter, so it will be creating a layer on the top of the section. So these three layers normally we get. Basically we get three layers: gas, oil and water. But if you have foam, then you will get foam layer. If you have interface, then interface means like there oil water mixture will be there because of emulsion, and there will be bottom layer solid section. So here gas density matters and liquid density matters. So liquid density, gas density difference is very high, so anyway gas will be creating a top layer. But if you see here oil and water case, if oil density very much lower or gravity very much lower and water density very high, water almost fixed density will be there, gravity will be there, but oil gravity will be changing based on your different types of oils you are using. For example, you may have one heavy oil or light oil, so based on that this layer will be formed so quick or it will delay for longer time. And interface, actually basically it will be like, if you have emulsifying agent, then interface will be stabilized for a longer period, so separation will not occur. So in this case, how to separate this oil and gas quicker, how to not to create interface. If interface is there, then how to reduce the time of holding that particle, oil particle there or water particle there, so that we will discuss in this lecture. And solid anyway sand basically, so basically it will be forming a layer at the bottom. The basic principle of oil separation, the pressure change, basic principle, pressure change. So pressure change causes more gas will be coming because loss of dissolved gas will be there, so the gas will be coming out from your fluid. Okay, so gas or low gravity fluid will be coming out, right? The temperature change, if you change temperature, then your density, viscosity will change, right? Density, viscosity will change. Okay, then gravity difference will be assisting in separation. Let's say one oil particle is here, oil particle, water particle is here, water particle is here. So water particle, how quickly it will be settling, it will be based on the density difference or gravity difference. Okay, so gravity difference between two fluid, oil and water. Then some other technique you also use to increase separation. For example, water particle from oil or oil particle from water you want to separate, then techniques, one technique is that gravity settlement. You take certain amount of fluid, okay, in certain bottle or any pot, and you give enough time, so automatically water will create one layer and oil will be creating another layer. Okay, so this will be oil, this will be water. So time is one important, so retention time important, right? Retention time. So retention time depends on many factors, so we'll discuss later. Okay, then if you have longer retention time, you have emulsifying agent, later we'll discuss emulsifying agent. So longer retention time, you can reduce the retention time or separation time using maybe electrical method called electrostatic coalescence, electrostatic method, or you can use mechanical method Okay. So, using mechanical, if you can create particle collision, so mechanical method, then particle will be colliding and it will make bigger particle will be separating quicker. Okay. So, smaller particle separation will be difficult. So, if you have bigger particle, oil particle in water, water particle in oil, it will be very easy to separate. Okay. So, using mechanical method, you can create bigger particle, you can separate, you can use electrostatic coalescence method, we will discuss. So, using that one also, you can create bigger particle and you can separate, you can use some chemical also. Let us say when you have one emulsion, two particle immiscible particle are there, but they are not separating quickly, maybe some chemical is helping them not to be separated. So, in that case you add some chemical and deactivate that chemical which is preventing to create bigger particle. So, some chemical method also possible. So, when you are separating, one is gravity separation, if there is no extra chemical or any impurities, the oil and water if you keep in a bottle, actually automatically it will be separated. Okay. Gas also will be separated because gas is very much lighter weight. Okay. And if you change pressure, gas will be automatically coming out. If you are changing temperature, then viscosity change, gravity change. Okay. Viscosity, gravity when changing, then particle settlement rate will be changing. Particle settlement rate means the oil particle from water, water particle from oil will be moving, oil particle will be moving up quickly, water particle will be falling down quickly. Okay. Falling down because it will create bigger particle. When bigger particle you are forming, it will be falling quickly. Smaller particle will take time. Okay. So, retention time will be longer for smaller particle. If you have very high viscosity fluid, particle will not try to move. For example, a hair gel you may have seen, lots of small particle will be there, it is not settling actually because viscosity is so high. Okay. Electrostatic coalescence. So, using electrical means actually you can create resonance in the fluid. So, small particle will be resonating and two particle will be colliding each other, it will make bigger particle. Okay. And chemical method, if some particle is having some chemical which is preventing to separate, so use another chemical to react, then you make bigger particle, you separate. Okay. Okay. Particle settlement, whenever you are separating oil and gas or oil, gas and water, oil, gas, water and sand, 4 phases or maybe 3 phases. Here one thing is that we say phases, liquid phase, gaseous phase, solid phase, right? 3 phases we know it from physics, +2 physics if you can remember. But here water and oil actually two different, we are saying phases, but it is not phase actually, two component of liquid. Okay. Single phase, liquid phase both. But in our oil and gas industry normally we use the term liquid phase and water phase, okay, and oil phase. So, that we say 4 phases, actually it is 3 phases. Okay. So, gas will be going out and you are creating different layers, right, oil, water, maybe sand also there. So, when you are creating layer, you are injecting fluid, you give certain time, it, so because of gravity, high density, high gravity fluid will be falling down, 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 it will be settling at the bottom, and low density, low gravity particle will be moving up. Okay. So, this will be controlled using a particle settlement theory. Okay. So, particle settlement theory is like this, let us say assume one particle is here, okay, and particle is trying to fall down in liquid. I have one liquid column, right, let us say this is liquid column and my liquid is moving up, okay, and this is maybe sand or maybe one liquid oil is moving up and water is falling down, that is also possible. This is force due to gravity, force due to gravity because it is trying to fall down. Okay. And another force because this fluid is moving up, maybe this is sand, okay, just assume sand solid. Okay. Because of this fluid moving up, it will be dragging up, fluid will be dragging up the particle. Okay. So, Fd is dragging up. Okay. So, then if my Fg is higher, then it will try to move down, if Fd is higher, it will try to move up. Okay. Now, mass of the particle m, mass, density rho p, mp you can write, density, assume this variables, fluid density Now fluid density rho fluid and frictional drag force, frictional drag Fd already I have given, and this is okay. Fg is a particle gravitational force. This is gravitational force. Okay, so Fg gravitational force opposing the drag force, right? Fg, Fg I have written a small letter. Fg minus Fd. Fd I have written capital. Okay, so m into dv by dt. Okay, acceleration due to gravity. Particle acceleration. Now v is settling velocity, and t is time. Okay, and Reynolds number equals from Stokes law v square r rho f. I'll write v square r into rho f divided by eta. Eta is the apparent viscosity. Okay, r is the particle radius, and rho f is the fluid viscosity, and v is the settling velocity. So spherical particle, we are assuming spherical. If we assume other shape particle, then there will be some shape factor. So for simplicity, just assume this is spherical. Okay, for spherical particle, Fd equals 6 pi eta r square, and frictional drag Fd half CD, C is the drag coefficient, rho f Vt terminal velocity, AP, Vt is terminal velocity, Vt equals terminal, okay, AP is the particle area of particle. AP area of particle means projected area. Okay, so dv by dt equals 0 when acceleration is 0. Okay, so finally this will be forming, if you assemble all together, Vt terminal velocity will come 2 r square rp square, rp you can write better, rp square g rho p minus rho f divided by 9 eta. Okay, this is the terminal velocity formula. Okay. Now from here what you can see viscosity increasing, Vt reducing. Okay, Vt proportional to inverse of viscosity, fluid viscosity, Vt proportional to radius square of particle. So particle radius means particle is larger, particle will have more larger Vt terminal velocity, means quickly it will be falling down, and that rho density difference, if you see rho p and rho f, if density difference is very high, again Vt is high. Okay, so larger particle size is more important because square term is there. Another part, linear relationship is there, like rho p, rho f, the difference is linear relationship is just proportional, but viscosity inversely proportional. Okay, so whenever you are solving any problem, you have to see the unit also. Here it is actually SI unit based calculation, and this is for Stokes, using Stokes law. So particle, we are assuming particle content less than 1% particle, particle concentration, and Re less than 0.5 I think. Okay, so this condition should be there. If you have changed Re value and particle concentration increased, so the formula will be changed actually. So that we are not going into further details for that. Okay, up to this one. Okay. Now gravity settlement. So same equation actually modified by your oil and gas industry people. because they want to use field unit. Okay, for field unit this extra constant term will be coming, and del SG specific gravity difference, and dm is the particle diameter square, and mu is the viscosity. So Vt term is unit feet per second. So you have to see unit here. Okay, del Sg means specific gravity anyway relative to water. Mu is viscosity C small c capital P. So here also you should remember small c capital P poise. Okay, so not both small or both capital, or not opposite also. Dm is particle diameter. Okay, and unit will be micron. Okay, if I give different unit you have to convert actually. Okay. Okay, so exponential will come same as before, like Vt proportional to del Sg proportional to dm square proportional to 1 by mu. Okay, so now if you want to get more quicker settlement means Vt higher. So if you want to increase Vt higher means del Sg you have to change. How to change? Del Sg is dependent on actually temperature. So you can increase temperature, you can change viscosity. Dm, so how to increase Dm? Dm actually whenever you can add one particle, two particle together, it will be bigger particle. So bigger particle means Dm larger now. Okay, now how to join these two particles? So there are techniques, so we'll discuss. And viscosity again it will be dependent on temperature. So we'll see how to change. Okay. Now based on the simple formula whatever you discussed, let's see one problem. A discrete particle settles in water. Okay, given data diameter of the particle 0.2 meter, just assumption. Okay, specific gravity 2.65, I think is sand particle specific gravity. Kinematic viscosity to 10 power minus 6 meter square per second. Water density is given 1000. Find terminal velocity. So here G value I think you should not forget, you must not forget actually 9.81, right? And if in field unit it will be 32, right, feet per second square. So water viscosity given, right, kinematic viscosity given. So from dynamic viscosity we are getting this one. So particle diameter is 0.2, this should be 2 millimeter, not meter. Okay, so terminal velocity Vt, this is diameter dm. So Vt will be 9.81 if you see the previous formula, then 0.2 into 10 power minus 3 millimeter is given. So you have to convert it to meter because you are calculating in SI unit, and then 2.65 is given, right, minus water 1000 and viscosity 0.001 and into 18, sorry 180. Why 18 is coming? If you see the previous slide actually, this 2 rp by 9. So rp if we put in diameter form, so diameter means it 4 term will be coming. So d equals rp2, right? So 4 term will be coming. So 4 if you calculate again, 2 and 9 is there. So finally at the bottom below 18 will come. Okay, so altogether if you calculate, your result will be like 0.03597 meter per second. Okay, now in exam what I can do, I can change some parameter, or I can just twist little bit and I can give this sort of simple problem. Okay, so you should be familiar that how the particle is getting settled and what are the parameters important for your particle settlement. Okay, so based on that actually now next you will be doing research. Okay, how to change my diameter, how to change viscosity, how to change my density. Okay, okay, emulsion. So whenever we are talking about emulsion, why emulsion term is coming? Actually emulsion will not allow particle to join and to make bigger particle. Okay, let's say you have oil and water mixture. Okay, and water particles are like this. Okay, water particle. Now if it is creating emulsion, then water particle will not make bigger particle whatever method you apply. So, because what happens, water particle will have certain coating around, because of this coating two water particle will not mix each other, okay, they will have one barrier. So, how to break the barrier, we have to understand now why the barrier is getting created and how to break the barrier so that you can get bigger particle, so that your Vt proportional to dm square, the dm you can increase, okay, your purpose is to increase dm, okay. Now, two immiscible fluid, water and oil is there and it is creating emulsion, okay. So, immiscible fluid is there and one particle is there, like say oil particle, water particle is there in oil, and two water particle not joining together. So, it is not joining, so it is not making bigger particle. So, the particle is not moving, it is called stable emulsion. So, particle is not moving at all, actually very small tiny particles are there, okay. So, for that one emulsifying agent should be there to create emulsifying agent, okay. So, one emulsifying agent should be there that will be coating the surface, that small particle around barrier will be created, okay, using that emulsifying agent, and two particle not mix. Then sufficient agitation you have to give. How to create agitation? When fluid is flowing from wellbore to the surface, so it is flowing through pipe, so lots of turbulent flow will be there, it is passing through choke, it is passing through maybe artificial lifting system, passing through different valves. So, lots of agitation already you are creating. Agitation, when you are creating, actually bigger particle you are breaking down to smaller particle. When you are creating smaller particle, immediately the emulsion will say, okay, I got a small particle, just coat it, okay, then they will be happy, they will not allow to mix small particle, okay. So, lots of agitation you are creating, okay. So, three things are there: immiscible fluid, okay, immiscible fluid, water, oil in our case, and emulsifying agent is there, so that it is not allowing to mix and to make bigger particle, and one agitation you are creating, lots of agitation, and you are creating very tiny particles. So, very tiny particles will not move at all actually, if you have high viscosity, tiny particle, okay. So, example of emulsion: milk on emulsion, okay, cream, lotion, lots of lotion you are using, those are also actually emulsion. So, normally you have seen everywhere. And stable emulsion, if you want to make, then particle must be very small, okay, very small particle. So, very dm is very small, so particle will not move actually. So, emulsion actually it is colloid form, okay. Colloid means very small particles are there in fluid and it is not moving at all. Emulsion, normally it will have a specific property, like it is bigger particle and oil and water mixture. In our case we are seeing emulsion, okay. So, two type of emulsion will be there: water in oil or oil in water, okay. Whenever you are creating emulsion, so you need one emulsifying agent. So, normally they are called surfactants, okay. So, emulsification will be happening because you have the emulsifying agent or surfactant. Emulsifying agent or surfactant, okay. So, if you have surfactant, then it will not allow to make bigger particle. So, what are the different surfactant? Surfactant like wax, it is there in wellbore, asphaltene, okay, wax, asphaltene, these are emulsifying agents. Sometimes I ask in exam, give some example, okay. So, what they do? They will be reducing interfacial tension, interfacial tension, creates small droplet, thin coating, okay, and aligns polar molecule. Okay. So, any fluid particle, if you say water polar molecule, if you see, this will try to create smaller surface area, okay, and if you have emulsifying agent, so it will create a smaller surface area, but two particle will not be colliding and to make bigger particle, okay, and emulsifying agent will try to create smaller particle and it will coat it, so that it will not move actually. Okay. Asphalting resin, organic acid, here some more examples are there. Organic acid, organic acid, bases, okay. And how this emulsifying agent works? Let's say we have one oil particle, okay, and emulsifying agent will be like this. It will have one end hydrophilic, and another will be hydrophobic. Here you can remember the name. Philic means loving, hydro water loving, hydrophobic means fear, right? Hydrophobic is it fears water, so it will be going away from water. So the going away that end of this molecule, it will have one end like this, one end like this. So this will be hydrophilic. This will be hydrophobic end. Okay, hydrophilic end will be outside. It will be around water, and hydrophobic end will be inside oil. Okay, so lots of you are creating like this, and it will be creating like coating around. Okay, so oil will have all around water. So one oil particle all around water, another oil particle all around water. So all around water it will be coating with water. So finally two oil particle will not meet. Okay, so this way they are creating separation between two particles. Okay, so this is hydrophilic or attracted to water, okay. Hydrophobic means attracted to oil. Attracted to oil, okay, that's not right, this one. So emulsifying agent partially soluble in water, partially in oil, okay. Because of that one they are creating coating around particle, and they are not allowing to make bigger particle. Okay, so it is a chemical compound. It lowers surface tension or interfacial tension between two compounds. Okay,